Hello again. This is Math 2231, and this is a video providing a key for the midterm high stakes assessment. Please be attentive learners while watching this video. Number one was a limit evaluation problem. If you factor out the -3, you have factors that you can cancel out. So you can substitute -2/3 into 4x minus 3, and you will get 17. Number two, this limit could be calculated directly, but if you make an observation that this is exactly f prime of 2, it's an easier calculation, and this is f prime of 2 for f of x equal 2x to the fourth minus 4x cubed plus 3x squared plus 6x plus 9. Was using the definition of the derivative and observing that f of 2 was 33. The easiest way to figure that out was to use synthetic division. The derivative of this function then would be 8x cubed minus 12x squared plus 6x plus 6, and that means f prime of 2 rather, again using synthetic division, is 34. Now, a typo on the exam was discovered as I recorded this video, and a generous correction was made across the board to your midterm scores. So you'll find that they're higher by about 3 percentage points. Number 3 was evaluating a limit. You do it term by term. You will get 3 over 4, 3 over 4, 1 over 2, and minus 3 over pi. And so the answer as you combine terms is 2 minus 3 over pi. Evaluating this limit, if you factor out the 2 over 5, and then you multiply top and bottom by the conjugate of the numerator, you will see that the 64's cancel out and the h's cancel out, and then you can take the limit as h goes to infinity. So whenever you substitute in and simplify, you get 1 over 40. Number 5, you're evaluating this limit. The observation is that this limit is the derivative of the secant, evaluated at pi over 3. So the derivative of the secant is secant x tangent x, evaluated at pi over 3, is 2 times the square root of 3. Problem 6, you should observe that e to the 2 ln x is the same thing as x squared, so this is simply a product rule. It's the derivative of the first times the second, plus the first times the derivative of the second using the chain rule, and we substitute x to be 2, and so we get 4 ln of 10, and that's the same thing as the ln of 10,000, and when we substitute here, we get 48 over 10, or 24 over 5 in those terms. So this is the answer you should have had for problem number 6. Problem number 7 again was the chain rule, and so g prime of x was 2 cosine of tangent of 2x times secant squared of 2x, and this 2 came from the chain rule. You substitute pi, and you find out that g prime of pi is 2. Number 8, the easiest thing to have done is to have done algebra. So if you distribute the x to the 2/3 across this, you get that h of x can be written as x to the 5 over 3 plus x to the 11 over 12. You take the derivative and substitute 1 for x, and you get 31 over 12. Number 9, you use the quotient rule. So this is the denominator times the derivative of the numerator minus numerator times the derivative of the denominator, all by the denominator squared. And you substitute 0, and you get 3 over 4. Number 10, you use the product rule, and you will get k prime is 2x cosine squared x minus 2x sine squared x plus 2 cosine x Sine x, you substitute pi, and you get that k prime at pi is 2 pi. Number 11, you were supposed to determine the values of b and c so that the function is continuous on the entire real number line. This is piecewise continuous, and so the left and right limits have to be equal for it to be continuous, and so you end up with this when you consider the limit x tending to 1 from the left and compare that with the limit as x tends to 1 from the right, and so you get b plus c has to be 1. And if you look at 3, the limit from the right of this expression has to equal the limit from the left of this expression. And so you get 3b plus c is equal to -5. You solve this, you get b is -3, c is 4. And the next slide verifies that this calculation is correct. Here you see it would be continuous as I go up here. So I go blue, then red, and then blue again. Here you were to do implicit differentiation and find the tangent line, the equation of the tangent line to the curve, and put it in form y equals mx plus b. So use implicit differentiation. First you note when x is equal to 0, y is going to be 3. Then you take the derivatives. That's where we found out that when we substitute 0, we get y is 3. But now you take the derivative using implicit differentiation, so it's 3x squared sine of y plus x cubed times cosine of y dy dx, plus then we come to this one, this is dy dx again, and then that's equal to 4. And so we substitute x being 0, this is 0, this is 0, and this, both of these, you're going to have dy dx evaluated x equals 0 then, is equal to 4, so the slope is 4, the point was 0, 3, and that means that y is equal to 4x plus 3. And the picture shows that that in fact is correct. Number 13, this is a rectilinear motion problem. A particle moves according to this thing, and this is the distance in meter from the origin at any time t, where t is greater than 0. The question was, how far does a particle travel during the first 6 seconds? Well, you take the derivative of the position function and factor it, and you realize that v is going to be negative until t equals 4, and then it's going to be positive. And so you start at 12 and you go in a negative direction until you reach 4. Now that means that you went 12 down, and then you went 44 over 3 down, but then you go back up again, and this shows what's happening. T equals 0, you're at 12. T equals 4, you're at minus 43 over 3. And at t equals that's 6, you're back to s equal to 0. You can see that from the graph here. And so the total distance traveled is 2 times this distance plus the 12. That's 124 over 3. Problem 14 was finding the extreme value on a closed interval, and so you evaluate the endpoints, and then you find the critical number. You take the derivative of this function, and you find that this is equal to 0 when x is a half. If you plug that in, you get minus 1 over the cube root of 4. So the absolute max is 2 comma cube root of 2, and the absolute min is 1/2 comma minus 1 over the cube root of 4. And number 15 was a related rates problem. Here's the picture. So you're sitting x feet from a wall, and dx dt is increasing at 10 per minute. At what rate is theta changing when x is equal to 8? And I gave you a picture to help you with that. And so here is again the figure abbreviated, and so you can observe that the tangent of theta plus alpha is 16 over x. that means that theta is equal to the arctan of 16 over x minus alpha, but alpha from the picture is also the arctan of 6 over x. So this is what theta is as a function of x, but x is also a function of t. So you're going to take the derivative with respect to t. So d theta dt is shown here. You have to use the chain rule, and notice that we're doing dx dt, and so we plug in the numbers that we have, and we'll find that d theta dt is going to be 1 over 10. So the answer should have been 1 over 10 for d theta dt when x was equal to 8 feet. In closing, you want to learn from this as you prepare for the final exam, but there's much to focus on ahead, especially with the home stretch incentive. And so let's be looking ahead and not back. Take care, my friends, and I will see you in class.